A few days ago, on December 19th, 2025, something pretty wild happened. 3I Atlas made its closest pass by Earth, at a safe distance of about 170 million miles, 270 million kilometers. This thing didn't change its path one bit, didn't react to Earth at all. We were just a blip on its long journey. What really has everyone buzzing, though, is that weird anti-tail, a tail pointing toward the sun, against all expectations. Right now, it's over 300,000 miles long, bigger than the distance to the moon. Anti-tails aren't new. We've seen them on other comets. But the size and how steady this one is, that's where things get strange. As you probably know, this is the third confirmed interstellar object we've ever spotted. It's zooming through our solar system on a hyperbolic path at about 37 miles per second relative to the sun. And its age? Probably billions of years old. It might have orbited another star long before our solar system even formed, a star that might not even exist anymore. Since it was discovered this summer, it's been telling its story through colors. It started out reddish from all the dust. Then, as it got closer to the sun, it released cyanide and nickel gases and glowed green. Now, post-perihelion, the dust is dominating, giving it a yellowish golden hue. Its chemistry is wild too. Rich in carbon dioxide, some water ice, nickel with low iron, and volatiles that activated way earlier than usual. This thing came from a place with totally different rules, an environment nothing like ours. Let's talk about what has everyone stunned, that massive anti-tail. Normally, comet tails get pushed away from the sun by solar wind, but this one, it's pointing straight at the sun, like it's staring right back. Photos from December 13th to 19th, taken in Thailand, Italy, and all over the world, show this structure staying narrow and straight, like a glowing sword aimed at the sun. In regular comets, anti-tails are temporary illusions that fade fast, but this one stayed locked toward the sun even after the nucleus rotated about 16 degrees at perihelion. Harvard professor Avi Loeb, in his recent posts, says this behavior is statistically super unlikely, though he notes it's his personal estimate, and most scientists don't see the odds as that extreme. The majority, NASA, ESA, international teams, say it's a geometric illusion, larger dust particles lagging behind due to radiation pressure and our viewing angle. But even they admit the stability and length are way beyond what we've seen before, a spin that's weirdly perfect. Another thing you can't ignore, the rotation axis of the nucleus. Most comets tumble chaotically, like a football thrown badly. But this one? It follows a pretty strict pattern. Its main axis, the imaginary line from pole to pole, stays aligned toward or away from the sun, with less than 8 degrees of deviation, and it's still doing that. Plus, the gas jets from the poles have a periodic wobble around 7.74 hours, but the overall axis stays locked on the sun. It's like one pole is always in constant daylight, the other in eternal darkness. Most folks say it's a rare but natural quirk from its age, chemistry, and long interstellar trip. As we're heading into late December 2025, it's been about a week since 3I Atlas's closest Earth flyby on the 19th. It's now pulling away fast, already farther than 170 million miles, and gaining distance every hour, like a ship disappearing over the horizon. Its apparent magnitude is around 13 to 13.5, so it's not visible to the naked eye or even regular binoculars anymore. You'll need at least an 8 to 12-inch telescope and dark skies. Right now, it's in the constellation Leo, near the bright star Regulus, moving a bit higher and northward each night. The gaseous coma is still visible, but the color has shifted. The intense green from summer has faded to a pale blue-green, with dust taking over for that yellow-golden look. That bizarre anti-tail is still one of its standout features. Images from December 20th to 21st show it holding a decent length and staying narrow and cohesive, though a bit fainter than at peak. Gas jets are still active, but way less intense than around perihelion. The big news? No signs of breakup or disintegration. The nucleus is holding together solidly, unlike some other Atlas comets that fell apart. NASA and big telescopes like Hubble, Gemini, and James Webb are still crunching the latest data. Parker Solar Probe images show it's cruising at constant speed with no unexpected deviations. It's entering a gradual shutdown phase, activity winding down, but we've got a few more weeks for good images before it fades out for good. Now the fun part, the debate. Harvard's Avi Loeb has been the loudest. He's pointed out about 15 anomalies in posts and interviews. His list includes the persistent narrow anti-tail, precise axis alignment, periodic jet wobbles, high nickel to iron ratio, and even a path that seems oddly optimized for planetary close-ups. He's keeping it at rank 4 on his personal scale, probably natural, but says these oddities demand deeper study. He keeps saying final data, like detailed spectroscopy of the anti-tail from Hubble or Webb, could change everything. Until then, it's worth discussing. The scientific community, the cautious take. On the other side, most experts, NASA, ESA, folks like the Atlas Discovery Team lead John Tonry, are super cautious. They say everything fits a natural, ancient interstellar comet. Anti-tail. Radiation pressure on bigger dust grains, plus our perspective creating the illusion. Axis alignment. Rare but possible. Maybe from nucleus shape or internal ice distribution. Non-gravitational acceleration. Tiny, way within gas evaporation models. Most importantly, breakthrough listens scanned for artificial radio signals and found nothing. Chemistry. CO2-rich, water ice, cyanide, nickel, matches an untouched interstellar comet perfectly. Yeah, it's weird. The weirdest natural object we've seen, but still natural. Loeb and a few others push back. Don't rush to judgment. This is our first close-up of an interstellar comet with modern tech. We might be seeing stuff we've never noticed before. This back and forth is exactly why the buzz keeps going, even after the flyby. From here, 3i Atlas is heading out steadily, no weird deviations. It'll pass near Jupiter's orbit around March 2026, then farther out, crossing Uranus and Neptune zones by 2027 to 2028. Eventually, it'll leave the solar system for good, back to interstellar space, where it came from billions of years ago. Our window for study is closing fast. Hubble, Webb, even advanced amateurs have just a few weeks for high-quality shots and spectra before it gets too faint. On one hand, we got a pristine peek at ancient cosmic material. On the other, tons of questions linger. That stubborn anti-tail, perfect spin alignment, nickel ratio, overall behavior. Maybe final Hubble or Webb data, still being analyzed, will clear some up. This thing is taking its mysteries back into deep space. Moving quietly in the dark, no bright glow, no noise, no witnesses left. Just a few telescopes on Earth catching final glimpses before it vanishes forever. What do you think? Is it just an insanely rare natural comet that nature cooked up? Or is there something more we haven't figured out yet? If you enjoyed this, hit like, subscribe, and ring the bell so you don't miss future updates. Thank you for your attention to Astreyon.